My name is Sanjeev Kumar Shah and my university ID is 2329256. My project title is Air Quality Monitoring System. For this project, I have used some of the components that are Breadboard, ESP8266, Wi-Fi module, MQ135 gas sensor, DST11 temperature and humidity sensor, Breadboard and LCD display, I2C converter. For this project, the breadboard are used to connect components, and for power supply, the ESP8266 Wi-Fi module comes with the connectivity which allows it to connect with the wireless network. And in this project, it is used for air quality parameters like pollutants level, temperature, humidity of the DST11 sensor, and the air gas value of the measure of the MQ sensor. For this project, breadboard are used to connect the component, these all components, and for the power supply, the ESP8266 which comes with built-in Wi-Fi connectivity which allows it to connect with the wireless network. And in this project, it is used for air quality parameters like pollutants level, gas value, temperature, and humidity measured by this DST11 temperature sensor, and gas value of the MQ gas sensor. After measuring these all values, it sends data to the Blynk which is connected to the Wi-Fi mobile phone. Now you can see that here the gas, the temperature, and humidity, and the gas value which is displayed on the screen LCD display are showing here. These all data are showing here, and it is updated as the data updates in the display. And this DST11 sensor is used to measure the temperature and humidity data and send it to the Blynk. As we can see here, the temperature and humidity measured by the DST11 sensor, and the data pin of DST11 is connected to the D4 of the NodeMCU, which allows the NodeMCU to receive the temperature and humidity data from the sensor. And the VCC pin of the DST11 sensor is connected to the positive rail of the breadboard, and it provides the power supply for the sensor. And the GND pin of DST11 sensor is connected to the ground rail of the breadboard, which provides a common ground reference for both the sensor and the NodeMCU board. This MQ sensor is used to measure the different gas value, and the pin of MQ sensor A0 is connected to the A0 pin of the NodeMCU, which is analog pin, and it reads the analog voltage value from the gas sensor. And the GND pin of the MQ sensor is connected to the ground or negative rail of the breadboard, and the VCC pin of the MQ sensor is connected to the positive rail of the breadboard, and which breadboard connection to provide the power supply for the sensor. The G pin of the NodeMCU board is connected to the negative rail of the breadboard. The ground pin provides the common ground for the board and other components connected to it. By connecting the G pin to the negative rail of the breadboard, we ensure that all the components of the breadboard have the same ground reference, and also the VU pin is connected to the positive rail of the breadboard, and pin and VU pin on the NodeMCU board represents the power supply voltage pin, which is connected to the positive rail of the breadboard. This pin provides the voltage supply of the NodeMCU board and any other components that requires power. By connecting the VU pin to the positive rail, we ensure that all the components on the breadboard receive the appropriate power supply which is required. For this project, here we have used I2C converter to communicate with the LCD display, and the I2C SDA pin is connected. SDA pin is connected to the D2 of the node MCU, and SCL pin is connected to the D1 pin of the node MCU. The I2C protocol is a serial communication protocol that allows multiple devices to connect over a two-wire interface, and the VCC and the ground pin of the I2C converter are connected to the positive rail and the ground rail of the breadboard respectively. The positive rail of the breadboard is typically connected to the 3.3 or 5 volt power output of the NodeMCU board on the voltage requirement of the LCD and I2C module. The ground pin of the NodeMCU board to provide a common ground reference for all the components. We are providing power to the LCD display with the help of or with the communicating to the I2C converter module through the breadboard power rail by SDA and SCL pins. Establish communication between the NodeMCU and the I2C module, allowing the NodeMCU to send data to the LCD display for output, and which is showing here after connecting Blynk to the our project. So we can see there it is updating as per the output showing on the display. Now the overall result of the project is that the system continuously measures the air quality, temperature and humidity. The readings from the sensor are displayed on the LCD screen using the I2C converter. The ESP8266 board communicates with the Blynk platform to send the sensor data wisely to a mobile, which is displayed on the mobile screen. And additionally, if the air quality exceeds a certain threshold, an email alert is sent to notify the user about the poor air quality. But now we can see that the air quality is not as much as poor, so no any notifications are showing here. Overall, the system provides real-time monitoring of air quality and environmental conditions, allowing user to take necessary actions or precautions based on the sensor.